Okay, let's start off. Next part. As you can see, testing your application in real environment like testnet is a little bit difficult because it takes time. It takes time, and there is some unexpected situation and unexpected operations. So I think it is one barrier to develop blockchain-based application. Okay, and next step is the final stage. We finally deploy and test all things to mainnet. But I don't do this to deploy my application to mainnet because it's totally the same as testnet scenario. You can just change some configuration like this. So instead of separate testnet URL, you can change mainnet URL, and instead of separate is you can use ethereum is, and separate Etherscan instead of separate Etherscan you can use just the Etherscan. So that's it. So it's the same as testnet stage. Okay, so I will wrap up this whole process. We learned the entire process of building the app with online borrowing the app. So we have 4 different pages. So it looks like a very long process to develop application. But I think we need this kind of rigorous process because smart contract is very critical programming. So because it is closely tied to financial assets. So if you have some small mistake, it can lead to big losses or big disaster. So we have to be very cautious about developing the app and testing the app. But I think in many cases, current DApp applications don't do this kind of rigorous process. Do you know why? In the blockchain space, people usually say the speed is the most important thing. So they ignore many things like testing or the process. They just copy some code and then test a few tests and then launch the service. It makes a problem. So we need to change this kind of environment situation. So you have to be familiar with this kind of rigorous process and testing. It makes your application safe and secure. Okay, it's the end of lecture 9, and we will move on to lecture 10. Okay. Lecture 10 will cover other tools like hardhat and ethers.js with different application token. And I will explain how to works when you call a smart contract functions. So first, in this lecture, I will use token example. Maybe people started programming Solidity and smart contract. Their first example will be token because there are a lot of token smart contracts. So, and many tutorials and many guides use token example. usually ERC20 token, but in this case, it is not ERC20 token. And this token example shows many cases, so it's very useful. There are two popular tools to develop contracts, Truffle versus hardhat. Truffle is the oldest tool, and it is very popular. It was very popular, and it has comprehensive documentation and resources. But these days, hardhat is more popular than Truffle. It is a new tool, and hardhat has many advantages over Truffle, such as error handling tools like console.log. So you can see some log messages from your console, your terminal, about smart contract. So before hardhat, we cannot see that kind of log message from in console terminal. We just emit events to see the log, and they provide a hardhat network. It's similar to Ganache, but you don't need to install different separated software. Just they hardhat embed hardhat network, and it is easier local blockchain environment. And you can customize hardhat with the plugins and tools task. And also hardhat embed use ethers.js as a default JavaScript library. Is more user-friendly and easy to use. So recently, hardhat is more popular. This is the evidence. Hardhat, it shows npm download trends, and hardhat surpassed Truffle's download since 2021. So in this class, I will use hardhat as a default smart contract development environment. We will develop a simple Token Dapp from hardhat tutorial. So you can see their tutorial. It is well documented, simple, and very comprehensive. And I hope you use this Dapp as a starting point or as a template for your Ethereum project. So you can clone the code from hardhat site, hardhat GitHub. So we will use these tools. So the first step, design. What is the problem? Problem statement. There is a fixed total supply of tokens. We just mint 1 million tokens, and it cannot be changed. An entire supply will be assigned to the owner of contract, who deploys this contract, and anyone can receive tokens. At first, contract owner has to send some tokens to another address, and this token is non-divisible. It means you can just transfer 1 or 2 or integer amount of tokens, not 2.5. And it is not compatible to ERC20 because it's not implementation of ERC20 interface. So it means you cannot see this token in your MetaMask wallet. So it's very safe. Okay, that's a design. There's a design page. So it's very simple. So I don't analyze this problem to make some diagram like a contract diagram, blah blah blah. Second step, you can understand and develop smart contract with Remix like this. This is the whole code. So it's maybe 39 lines. So it's very simple, and I don't I will not explain line by line, but I want to note one thing. You can see console.log in the function of transfer. So when transfer function is called, console.log will emit some message in your console. So it's very convenient way to check the status of your function. So next step is deploy and test the smart contract in local environment. When you after installing hardhat, we will run npx hardhat command, and you can choose one of three options, and you can get some template folder structure when you choose JavaScript project or TypeScript project. And there is very useful plugin, hardhat toolbox. So I recommend to install hardhat toolbox. And put token.sol to contract folder, and then compile. And we will test this contract using test script, token.js. This is test script. It's very similar to the previous Ballet test script, because hardhat also use Mocha testing framework and also Chai assertion library. So it's very similar. But in this case, they used ethers.js as a JavaScript library. And this is the part of developing a web application. In this case, we used the React, and so this is the React file. I will explain this part a little bit later. And then we can deploy and test all these components into local environment. Before deploying our smart contract, we need to run hardhat network in local computer. It's npx hardhat node command. And then deploy contract with the command npx hardhat run script deploy.js. Deploy.js is a script, JavaScript to deploy contract. So we have to write this deploy.js script. It looks a little bit difficult, but not that difficult. So this script has some code to copy some data into files to use them in a web application. So I will explain this file later. And then we will run React web application and open this page. At first, every account don't have this token. So contract owner has to give some token to this address, to this account. So this tutorial this tutorial already provide poset task, poset script. So contract owner can, developer can use this poset script to send tokens to other address. So and then every other accounts can transfer their token to others. Okay, I will show this demo with video. This is the last demonstration. This video shows how to deploy. This video shows how to deploy and test the smart contract with hardhat into local environment. We already programmed and tested token smart contract with Remix. So this is it. And okay, let's compile this one. npx hardhat compile. So actually I already compiled this one, so nothing to compile. And then we need to test this contract. So we should write test the script like this. It's very simple, just a 2-unit test. Okay, test. We passed the 2-unit test, and you can see some log message. It's very big, huge advantage of hardhat. When you put this console log, you can get some log message from console. So it is very good way to test and debug smart contracts in console. Okay, the next step is to develop a web application part, but we already have that. We assume we already have that kind of front-end code, and so the next step is run hardhat network in local computer. npx hardhat node. So this command will run a hardhat network in PC, and this network provide 20 test accounts like this. Okay, and we are ready to deploy our smart contract into hardhat network. So npx hardhat network localhost run script deploy.js. So this command will deploy smart contract into hardhat network. So this is deploy.js script, and we need to put hardhat network configuration into this. Okay, we have to run web server, React web server, and pm run start. Okay, we got the simple web page, and we need to configure MetaMask with test account of hardhat network. So as you can see, 7 already I set up 2 different accounts like this, so we can connect wallet into hardhat network. Connect, and then update it this web page, but we don't have KAIST hardhat token 0, so we wanna get a token from posets. So we need more okay, wait a minute. We need more command share and token, and then okay. So when we got 100 KHT, and so we can send this KHT to other node, like this one. So change the account. Okay, we will send 40 KHT to this account and transfer and gas P. Okay, let's see that account. Okay, 40 KHT. So we developed token contract in a hardware network environment. Okay, it's done. Okay, this is the last demonstration today's class. Okay, get back to the slide. So actually, it looks simple, but when you run this kind of code, there may be some trouble. There may be some trouble about configuration, or I don't know, if you have some question and trouble, you can ask them to in Discord. Maybe other mentors or TA will help you. Okay, next step is deploy and test this contract into testnet. But I will leave it as your challenge. You can do that. You can refer to previous example as a guide. It's very similar process. So give it a try. Okay, so far I explained how to develop DApps using hardhat development tools. So from now on, let's talk about JavaScript library, Ethereum JavaScript library, ethers.js. We already explained a lot of things about developing smart contract, but when it comes to developing web application part, you need to be familiar with ethers.js. So I will deep dive into ethers.js. There are two most popular Ethereum JavaScript library, Web3.js and ethers.js. Web3.js is the original one, and it's extremely popular. So many DApps and smart contracts already used Web3.js, but it's a little bit heavy. So it is a few megabytes. So recently, many people moved to ethers.js. Ethers.js is extremely lightweight, 77 kilobyte compressed. So it's very light, and it is more user-friendly than Web3.js. So in this class, I will use ethers.js as a default JavaScript library. So popularity, and this shows the popularity of ethers.js compared to Web3.js. ethers.js has several classes on blockchain things. So when we develop application on blockchain, we have to control some stuffs like account and blockchain and contract. So account and contract classes about contract and classes about blockchain. So signer is an Ethereum account. So it means you can use this signer class to sign transaction to blockchain, and this signer class will control your private key to sign your transactions. But this signer class is an abstract class. It means you have to use subclass to implement signer class. Wallet is the most popular subclass of signer. So it implements a standard EOA account. So you can use wallet to sign transaction and send messages using your private key. So these classes provide many functions to get address or get balance of this wallet and send a transaction with this wallet. And next one is contract related classes. Contract class is an abstraction of a contract deployed on the Ethereum. So you can access your contract or others' contract with contract class. And contract factory is a factory pattern. So this is a factory class to deploy a contract. So we use this contract factory to deploy our smart contract in deploying script like deploy.js. And last one is provider. Provider is a class to interact with blockchain. So you can get any information and any data from blockchain using provider. So maybe you will use provider a lot. It is a read-only connection to blockchain, and you can extract any information like balance or gas fee or transaction information. But it is also abstract class. So, but there are many subclasses to implement this provider class. Upper three provider are most popular subclass. So default provider and JSON-RPC provider and Web3 provider. You may use default provider and JSON-RPC provider in your computer to interact with blockchain. But when you use MetaMask, you will use Web3 provider in your browser. Or many companies like Impura, Alchemy, Ethers.js, they provide third-party providers. So they add some more functions into this provider. But so you can choose this one. But I think default provider or JSON-RPC provider or Web3 provider are enough to use. So ethers.js provide many useful classes to interact with blockchain like this. Hardhat provide some useful plugin to help you to use these classes. So these are helpful functions. So get contract factory, get contracted, get signer. These are helpful functions. So you don't need to worry about creating your own classes using ethers.js. You can use these helper functions, and then you can get some classes of ethers.js. Okay, we addressed we addressed ethers.js in more detail, and I will explain ethers.js using code. This is the part of deploy.js. Let's look at line number 2. Ethers get signers. It is a helper function of hardhat plugin. So when you call this function, you can get a signer class instance. So this signer instance from blockchain network. So deployer contains the signer instance. It is a contract owner, and you can get some information about contract owner, and also contract factory. Line number 10, ethers get contract factory will return contract factory instance, and then you can deploy your token contract with this contract factory. It's understandable. And next one is poset.js. It is the part of poset.js. As you can see, they used helper function a lot. So line number 1, 2, get contract add and get signers, ethers get signers. Those are helper functions of hardhat. So when you call ethers get contract add, argument will be contract name and also contract address. We can extract contract instance with these two information. And then okay. Let's look at line 4. Line 4. This is about calling contract function transfer. So token dot transfer will call transfer function. So it is a transaction about calling a function of contract. On contrary, line number 7, in this case, sender dot send transaction is a different transaction. It is not a core of smart contract. It is a regular transaction. So sender is a contract owner in this case, and then contract owner send transaction to send sender's ether to receiver. So it is regular transaction to send ether to others. So this script contains two different types of transaction on Ethereum. Okay, next one is token.js testing script. In this testing script, we can see many ethers.js functions and also helper functions. I already explained many things with the previous code, so I just mentioned one thing. Let's look at line number 4. Ethers get signers will return many signers instance from Ethereum from blockchain network. In this case, hardhat network. So because we are testing, so we just use the first 3 accounts. So owner is a contract owner, and second account and third account. And then we will put this account and contract instance into return variable, and we will reuse these functions in each unit test. So this code shows that kind of things. Okay. So far, we explained some JavaScript code, but this code will run on our local computer in terminal. It means it is server part. This code will run on server part, but web application like front-end page and web application will run on browser client part. So it's a little bit different. So eth.js is a main JavaScript code of web application. In this case, we have to call MetaMask to use MetaMask account. So Windows Ethereum is a kind of provider, JavaScript Ethereum provider. So either Windows Ethereum will handle any other calling any other functions to interact with blockchain. So line number 3 is a very common usage of Windows Ethereum. Windows Ethereum.request will submit RPC request to blockchain through MetaMask, and it is a wrapper function. So you can customize this function with argument like method. So in this case, method is ether request account. So this call will return account. So this function after calling this function, you will get account of MetaMask, current account. And there is another Windows Ethereum function on. So line number 8, you can see Ethereum on. Ethereum on function is listening for events. So it's unique in browser on browser because users can change their account in MetaMask. So this code web application can should detect the account change. And also users can change their network. So web application should detect the change of network. So Ethereum on can do that. So this web application can detect the change, and then state will be changed. We have to put some code to change the state. Okay, and line number 30, there is a provider. So either providers, Web3 provider is initialized Web3 provider for interacting with MetaMask, as I said. Okay, and last part, line number 34. It creates the instance of contract token contract instance. Let's look at arguments, contract address, and ABI file and signer. So if we have contract address and ABI, we can communicate with contract. We just need two information. They are interface, the interface to interact with smart contract. Okay, so MetaMask provide, Ethereum provide API. So when Windows Ethereum is called, MetaMask injects a global API into website. So we can use Windows Ethereum provider, and we can do everything about blockchain. Okay, I already explained all these things. Okay, so you have to understand ethers.js JavaScript library to make to create your web application part, and also you need to understand MetaMask Ethereum provide API to use MetaMask as a wallet in your web application. But I don't explain the detail under the hood. What happened when we call a smart contract function? I recommend you understand this detail, because if you understand how it works, you can easily debug your program solidity, and you can use some console tool to test your smart contract. When you compile your Solidity code, token.sol, Solidity compile generate two different parts. One is bytecode, and the other is ABI file. So bytecode is a smart contract information in binary format, and this bytecode will be stored on Ethereum virtual. It will be stored on Ethereum, and so Ethereum VM will understand how to run this bytecode. An ABI file. ABI is application binary interface. It is an interpreter that facilitates communication with the EVM bytecode. It is a human readable JSON format, so you can read ABI file. So when you deploy your smart contract, actually this bytecode will be transferred to Ethereum. So this bytecode will be pegged into transaction in data section, and then Ethereum will store this bytecode as a contract. This is an ABI file. You can see this ABI file from front end folder, token.json. I extract some code snippet from token.js, JSON, event and balance of function. So event, transfer event translated into ABI like this. You can understand this ABI part is very understandable. It is easy to understand. So type is event, and this ABI part shows three different input argument, so name and type. And right part is balance of function. So balance of function is type function and input data type and output data type and function name. So you can understand smart contract with ABI file. So this ABI file will be used in MetaMask or your web application to interact with your smart contract. When you call a transfer function of token soul, what happened? How this data will be transferred to Ethereum? This function will be encoded into binary format. It is ABI encoding. So transfer function transfer the function name and argument data type will be put into kaka hash, and then we get hash code and extract first the 4 bytes, and we can make function selector like this. And then we have 2 arguments in transfer function. For example, we the first argument as an address. So this address will be padded to 32 bytes like this, and this function send 10 tokens. So 10 is padded to 32 bytes. So we make 3 different parts and combine these 3 parts, and we get these binaries. And this binary will be embedded into transaction. So in blockchain, in Ethereum, when we call a smart contract function, it is a transaction to call, to send this data to smart contract. Okay, so how to call before explaining this one, I will show you Etherscan page to show this kind of data. Okay. Oh, I already share the Etherscan page. Okay. This is a Etherscan page of Seporia. I already deployed token contract to Etherscan to Seporia. So that's it. And I transferred like this. Finally, we can understand this Etherscan page. Etherscan page shows all information about our transaction. So this transaction transfer token, this token to this smart contract from account, this smart contract, and this smart contract will transfer this token to this address, and you can see input data. Input data is binary, as I explained. So Etherscan just translate this binary into readable text like this. So this is a function and 2 arguments like this. So we can see original. This is the original. So in this transaction contains this binary data into data section. And also you can see transaction received. As a result of this transaction will write a transaction receipt, and then we can extract this receipt information with another transaction, another core, a JSON-RPC core. I will explain this later. So as you can see, receipt contains this information. This information is about events. So when we call transfer function contains events, emit event, transfer function emit events. So these events will be written in transaction receipt like this. So from address and to address and amount of transfer. Okay, so you can understand all things about transaction or function call in etherscan. Okay, let's get back to slide. Okay. So how to send a transaction to Ethereum? This is JSON-RPC core. So you already saw Windows Ethereum .request function. So this function will make JSON-RPC core request and then send to Ethereum like this. So it is JSON format. So the method name is a send transaction, and this transaction contains several parameters from account and the information about gas and to account, and value is about ether, the amount of ether to send, and data section. Data section contains the data about function call, and we will get 32 bytes transaction hash as a return. It is a asynchronous call because it takes time, so we cannot get result immediately. So after getting transaction hash, web application or wallet will send another JSON-RPC core like ether get transaction receipt with transaction hash, and then we can get return like this. So after that we can see the result of transaction and also the events in log section. In log section, you can see events. So if you want to log some data when smart contract function is called, you need to emit some events in your smart contract, and that events will be written in logos, and you can see that logos in your web application part. So that is JSON-RPC. So when you call some functions in your web application or console command like test script or deploy script or process script, they every time they just send JSON-RPC core to RPC node. So if you understand all these things, you can analyze this RPC core result or RPC core itself, and then you can debug or you can use many tools for RPC core, JSON-RPC core. Okay. This is the last part of how it works. There are 3 different types of transactions. The first one is regular transaction. Regular transaction is transfer ethers to other account. So it is regular. So there is from account. There are from accounts and to accounts. But when you execute your contract, to address will be a smart contract address. So, and also this transaction contains data part, data section, as I explained. And the last transaction is contract deployment transactions. In this case, there is no to address because it is about creating your smart contract. So there we don't need to address. In this case, transaction contains smart contract bytecode in the data section. So that's it. If you understand all these things, it is about how smart contract function is called. Smart contract function for works. So okay, but it is a little bit technical part. Okay, I'd like to wrap up. We learned many things in this lecture, building Token Dapp. And Token Dapp, Token Dapp is very common to develop at first in blockchain space. So you can add more functions, or you can modify this contract to study more. And you already learned the hardhat-based smart contract development and ethers.js and MetaMask Web3 provider. And you finally, at last, you learned what happened in calling a smart contract. And I'd like to note something lastly. In this domain, many people just simply copy and paste contract code without understanding how it works, because there are tons of smart contracts. You can read this smart contract in etherscan, because smart contract is basically open source. So you can copy smart contract very easily. So copy and paste. Many people do that. So any bug and any errors will be transferred to other DApps and other smart contract. So I recommend, I want to say, you should be careful when copying code and try to understand how it works. You have to understand how smart contract works, and behind smart contract calling, blockchain and web application, how to interact between web application and smart contract. And if you understand how it works, you can be cautious to use others' smart contract. Okay, that's the end of today's lecture. So I will check some questions in chat box. Okay, you will encounter several errors building. Okay, this is from TA, and last demo the gas P was spent, but I will read the question. In the last demo, the gas fee was spent, but it seems that there is not reflected in any accounts balance. Isn't it correct that the gas fee was deducted from the balance of the sender or receiver? This gas fee will be reduced from sender, not receiver, sender. So there is some calculation method to calculate gas fee. So as I explained, that Java's JSON-RPC parameters contains gas price and max gas fee. So I put some URL reference to understand how to calculate this one in Ethereum Foundation, so you can see that things. So gas fee definitely will be reduced in testnet and even in local environment, except when your call is failed, like reverted. Oh, okay, already TA replied. Okay, you already saw this. Oh, thank you for TA. Thank you, TA. So, okay. All questions are replied by TA. TA are where TA has many experience to develop DApps and smart contracts. So we are preparing some different session, some separate session to share his knowledge to you, to project teams. So maybe we will make that kind of session to share advanced technology to develop smart contract and how to configure this environment. Okay. Any other questions? We already 6:43.